Hello, Longhorns. Dr. Kelly again, and today we'll be taking a look at scientific notation. We know that scientists around the world have to communicate with one another, and there are hundreds of languages that we can translate between. The one thing about physics and math in general, science and math in general, is that numbers are universal. We use scientific notation as a way to communicate either very large or very small numbers, but it takes a little getting used to make sure that what you have on your paper and what's going into your calculator for your equation is really going to give you the results that you're looking for. So, first example, let's say that I give you the following number. You're given 10,477 meters, and you're asked to place this number into scientific notation. One of the common misconceptions is there's no decimal that appears right away. So you have to figure out, where does my decimal exist when I'm dealing with a whole number? Well, we've learned before, your decimal actually is going to start at the end of that whole number, so behind that last digit. I can move my decimal in two directions, and this is one of our two rules. If your decimal moves to the right, your exponent will be negative. If my decimal moves to the left, my exponent will be positive. And when I'm talking about exponents, you're going to notice we use the power of 10, and you'll see a little number at the top, which can either be a 3 or a negative 3, and it tells me if my decimal was moved to the right or to the left. In the example that we have, with 10,477 meters, coming up to rule number 2. The number in front of your decimal has to be between 1 and 9. So we're going to keep moving the decimal until what's right in front is either a number between 1 and 9. So let's count how many moves this is going to take. 1, 2, 3, 4. And my new decimal is going to end up there. If I was rewriting this on my paper, then I would put 1.04 times 10, and then you got to pay attention. How many places did we move the decimal? 1, 2, 3, 4. Because we move to the left, your exponent will stay positive. Let's try another one. What if you're given the number 678.940 seconds? Whoa, we have numbers in both directions, right? Well, keep in mind, if I move the decimal to the right, my exponent is negative. If I move the decimal to the left, my exponent is positive. And the other thing is, in front of the decimal, after we've moved it, the number has to be between 1 and 9. All right? So, if we move our decimal to the right, will that allow us to have a number in front of it that's between 1 and 9? The answer is no. If we move it to the left, we can definitely get there. So let's go to the left. How many spaces would you move it? Work it out, and let's see if our answer is going to match. 1, 2. If you're looking at your number that was originally 678.940 seconds, then our new number would be 6.78 times 10 to the second seconds. If you're asked the question, why is your exponent positive? It's because you move to the left. Now, we've been moving our decimal to the left. What happens when the decimal has to move to the right? So you're given the following number, 0.00463 meters. Well, our rules still apply. So, first rule, think about it. Do we want to move our decimal to the right or to the left? In this example, I'm thinking to the right. So our decimal is going to move until we have a number in front that's between 1 and 9. 1, 2, 3. Because 4 is between 1 and 9. What would your new number be? 4.63 times 10 to the negative third. Whoa, Dr. Kelly, why is that exponent negative? Because we moved in what direction? We moved the decimal to the right. Remember, the right is negative for exponents, and the left is positive. Let's do one more example. If you're given the number 0.83046 meters. Another thing that kind of throws students off a little bit is when you give them that 0 in the middle of their number. What do? Well, think about your rules. Remember, we only have 2. Rule number 1, if I move my decimal, the number in front has to be between 1 and 9. So, how many spaces do I need to move? In this example, you're only going to move what? Just 1. Awesome. Your new number would be 8.30 times 10. Is that exponent positive or negative? It's negative. It's negative 1 meters. And that's scientific notation. Today we learned that scientific notation is the way that scientists communicate very large and very small numbers. We also learned that your exponent can either be positive or negative. When moving our decimal to the right, our exponent will be negative. When moving our decimal to the left, your exponent will be positive. If you need any help, feel free to send me an email. As always, there will be a link attached at the very end of your PowerPoint if you need to see another explanation. And there are practice problems as well. I'll see you guys.